So in this video, I am talking through the notes for residual plots. These are the notes that we did yesterday, which was Monday, January 7th. So a residual plot is a graph that shows that the difference between the actual data and the predicted data. When I say actual data, that is the information given to you in a table or graph. This will be the data that would create a scatter plot. The predicted data is going to be what the model says should happen. This is going to be your data that is on your line of best fit. So how we find a residual from these two types of data is taking the actual data and subtracting the predicted from it. Another word for the predicted data is expected data. So what is this going to look like? So the independent variable is going to be graphed on the horizontal axis. When we talk about horizontal, it's going to be the axis that goes from right to left. On a normal graph, when we talk about the axis that goes right to left or left to right, we're talking about our x values. The residual values are going to be graphed on the vertical axis. So when we talk about a vertical axis, we're talking about the axis that goes up and down. And typically on the coordinate plane, these will be our y values. So if the residual plots are randomly scattered, around the horizontal axis, a linear model is the best choice to model the data. If the residual plot shows a pattern and does not appear to be random or scattered, a nonlinear model would most likely be a better fit. So a few examples of determining whether a linear or nonlinear model would be the best choice for the data is these examples. So these examples are representing not the data and not the predicted data, but their residuals themselves. So looking at number 1, the points are everywhere. Even if we connected the dots, there is no pattern to these random scattered plot residuals. So on our sheet of paper, it already says it for us. There's a random pattern. So the line of best fit would be a linear model for the actual data. For the second one, there's a distinct U shape in between the residuals. So because there is a pattern, then our line of best fit is going to be a non-linear model. Same thing with number 3. There's a distinct pattern of an inverted U shape. So our line of best fit is going to be a non-linear linear model. So how does this look with an example of actual data and finding our residuals? So we're given a set of data points. In our years, we want to change it to simpler numbers because I don't know about you, but I don't like working with big numbers. So we're going to create 1992 as our 0. If we create that as 0, we've got to look at it to see how many years are in between 1992 and 1993. So we've got to put 1 for 1993. Then in between 1992 and 1994, there are 2 years. The next one would be 3. I'm trying to make it thicker for you to see it. Next one would be 4, 5, 6, 7, and 8. Now, to enter the data into your calculator and to find the best fit, what you want to do is go to second 0 and go to your catalog. Once you go to your catalog, you want to find diagnostics on, and you want to hit enter until it says done. Once it says done, it is on, so you can also find your correlation coefficient while you're finding your line of best fit. Once you turn your diagnostics on, you're going to go to Stat Edit and type in the values that we just did. Your years are going to go under your L1, and your active clusters are going to go under L2. Once you type this data in, you're going to go to Stat again, and you're going to calculate something. So you're going to go over to Calc, and you're going to calculate the linear regression, which is number 4. Once you hit linear regression, you're going to, before you hit enter for it to calculate it, and I showed you this, if you want to use it, you can. If you don't, you don't. But you can go talk to Mr. Vars and ask why Mr. Vars. So you're going to go over to y-vars, and you're going to select functions. And then you're going to hit enter until it gives you your line of best fit. Once you do this, then your equation, or your line of best fit equation, will be saved under y equals. So, before you do that though, you have to write down what your line of best fit is. So y equals 3.7 x plus 19.9. And then your correlation coefficient was 0.984. So again, the reason why we did all of those crazy steps is so once we saved it with Mr. Vars, we can look at our table on our calculator to get our predicted values. So remember, all of these are 0, 1, 2, 3, 4, 5, 6, 7, 8. And our table is telling us our predicted according to our line of best fit. So all of these should be 19.867, 23.567, 27.267, 30.967, 34.667, 38.367, 42.067, 45.767, and 49.467. So once we have our predicted and our actual is given again for us, then we're going to look back at our notes and see, to find our residuals, we're taking our actual and subtract our predicted or our expected. So we're taking our actual, which is 22, subtract our predicted, which we would get 2.133. So the next one, we would get 24, subtract 23.567. You would have a 0.433. Next one, you would have 27 minus 27.267. And some of these you can do in your head, others you can't. So use your best judgment on these. So I'm just going to go down and copy down what I have. So now we have our predicted values, we have our residuals. So now we can answer a few questions about this set of data. So the next thing it asks us to do is graph our residuals. So how we graph this, I'm not going to do it in this program just because it's not copying my graph correctly. But it says to find the residual plots, we need to find the difference between what actually happened and what is predicted to happen. So now let's construct a residual plot. On the horizontal axis, which is the axis left to right, will be our independent variable. So remember, our independent variable is our x values. So our x values, it even says it in our table, our x values are our years, or our values that we put into L1. Now, our vertical axis will be our residual values. So our vertical axis is telling us that our residual values are going to be our y values on our graph. So that's going to be the up and down one. So if we look at our table that we spent so long creating, it's going to make it easy for us to create our ordered pairs that we are supposed to graph. So we're looking at our x values and our residuals and creating our ordered pairs. So we have 0, 2.133. Then we have 1.433, 2 and negative 0.267. And I'm just going to keep going down and hopefully I won't run out of room. Negative 3.967, 4, negative 0.667, 5, 1.633, 6, negative 0.067, 7 and negative 0.767, and 8, 1.533. So once we have all of these ordered pairs, that is what you will graph in this graph that is on your sheet of paper. So once you graph it, you are answering, would you describe the residual plot as scattered and random, or do you actually see a pattern? And then once you determine if there's a pattern or not, whether the line of best fit would be linear or nonlinear. And that's where you go back to the first part to figure out if it's linear or nonlinear.